Okay, I'm going to work through 3 examples of absolute value here. So stick with the whole video. We've got find all numbers t such that the absolute value of 3t minus 4 equals 10. So again, it's always good to draw a number line with these absolute value problems. Here's 0. Let's say that's 10. Let's say here's negative 10. So to say that the absolute value of something, so here's our something, 3t minus 4, but it doesn't matter what it is. The absolute value of something equals 10 means its distance from 0 is 10. So this thing must either be actually be 10 or be negative 10, because the only thing that has an absolute value of 10, the only two things, is 10 or negative 10. That is, 3t minus 4 must equal 10, or 3t minus 4 must equal negative 10. That's the only way that it could have an absolute value of 10. If I take the absolute value of something and I get 10, that means that thing that I took the absolute value of must have been either 10 or negative 10. So here we get 3t equals, add 4 to both sides and I get 14, or 3t equals, add 4 to both sides, and what do we get? Negative 6. So we get, divide both sides by 3, and we get 14 thirds. T equals 14 thirds. Or, here, divide both sides by 3, t equals negative 2. Okay? So that's when the absolute value equals a number. So again, equals. So we're going to do the same problem and change it just a little bit. Let's look here at number 5. The same problem, but now we have the absolute value of 3t minus 4 is less than 10. Here's 0, negative 10, here's 10. Okay? If I say that the absolute value of something, no matter what that something is less than 10, that means it can't be no bigger than or equal to 10, so it has to lie in here, or the distance between 0 and 10 is less than 10 for everything inside here. That is, it can't lie out here, because then its distance from 0 would be more than 10, thus giving it an absolute value bigger than 10. It can't lie out here because, again, its distance from 0 would be more than 10. Okay? Let me erase those, get those out of the way, because they're just not true. So looking at this here, we see that 3t minus 4 must be bigger than a negative 10, and 3t minus 4 must be less than 10. Again, students, I know you guys and gals find these problems very difficult. They're much easier if you will stop and think and make them make sense, and you use your number line here. And when we see this, it's clear to me that I'm bigger than negative 10 and I'm less than 10. So that gives me 3t is bigger than a negative 10 plus 4 is going to be a negative 6, and 3t is less than, if I add 4 I get 14. I get 3t, oops, so this is going to be t, divide both sides by 3, t is bigger than a negative 2, and t is less than 14 thirds. Okay, so this gives me negative 2 to infinity, that's t is bigger than 2, and as an intersection, intersected with a negative infinity, 14 thirds. Okay, and let's take a second and look at that on the number line. So here's 0. I'll say here's negative 2 to infinity. Negative 2. I don't get negative 2, but we go out to infinity. I intersected with 14 thirds. What's that going to be? About 5. So somewhere, oops, let's say out here. 14 thirds. So we don't get it either. Oops, so let's go up here. But we get everything less than it all the way out out to infinity. Okay, and is the intersection, so we see that our intersection lies in here. All right, we don't get that endpoint because it's in this one, but it's not in that one. Here, this endpoint is not in that one, but it's in that one, so we don't get it. The intersection has to lie in both of them. So we get that this intersection equals, it's going to be open a -2 to 14/3. Okay, that's that one. Now let's change this piece again. Look at the next problem I've got here, and we're going to make it a greater than 10. So find all numbers t such that the absolute value of 3t minus 4 is greater than 10. Again, the first thing I'm going to do is go to the number line. I always go to the number line with these and think about it. Here's 0. Let's say here's 10. Here's -10. And so the absolute value of something, again, I don't care what it is. It happens to be 3t minus 4, but anything that I take the absolute value of, and if it spits out a number greater than 10, then it had to live out here for its absolute value to be greater than 10. Or it had to live out here. And again, when people want to say when to use and, when to use or. Well, if you draw the number line and make it make sense, I see here it's either less than 10 or bigger than 10. I mean, the number line tells me exactly what to do here. That is, I get 3t minus 4 must be less than -10, or 3t minus 4 must be bigger than 10. Okay, so I'll just add 4 to both sides, get 3t is less than, when I add 4 I get -6, or 3t is bigger than 14. So divide by 3 and we get t is less than -2, or t is bigger than 14/3. Let me pause for a second. Okay, so this gives me that what is this set here? T is less than 2, so that's going to be negative infinity and -2, or that's going to be a union. T is bigger than 14/3, so that's 14 divided by 3. Oops. 14/3 to infinity. Okay? So my solution is my solution set is t such that t is in this set. Let's see how they write it in here. They don't even give one of these. So such that t is in the set, or in the interval negative infinity to -2 union 14/3 to infinity. So that's my solution set. All t is such that t, and this means, this little symbol here means t is in this union of intervals here. Okay? So that being said, let me go back. I don't think I stated the solution set here, so let me state this solution. So this is a solution set is going to be all t such that t is in this interval from -2 to 14/3. Okay? And that's going to conclude those 3 problems. Watch these carefully. Always when you have these absolute values, draw the number line, make it make sense. The absolute value is the distance from 0, and these become much easier. They're very difficult until you can grasp that idea that it's simply just the distance from 0.